Hi, Dr. Harris here with our video for our second slideshow from Chapter 3 in our data computing course. Still talking about the grammar for graphics using ggplot 2. Just a reminder, if we're kind of thinking about this picture, about how we're looking at things in this course, we are still looking in the visualize phase here in Chapter 3, where we're trying to convert data to graphics. And the first part of this slideshow deals with what can be called univariate displays, una meaning one. And so we're looking at graphing just a single variable inside a frame in ggplot. And so our the first data set that we're going to look at here is the current population survey from 1985. The data set is known as CPS 85, and it's in the package Mosaic data. And so we maybe could copy and paste these commands in here just to get a feel for what is in CPS 85. So we'll go over to our studio, paste this in. And so here's our data set, our help file, and it says it's used to supplement census information between census years, information on wages and other characteristics of workers, including number of years of education, work experience, occupational status, and so on. And so one of the variables that's in this data set is wage, and that's the variable that we're going to be doing some work with now and later on in this slideshow. And so this is data that's now 35 years old, but we can still attempt to analyze it. So what are some examples of univariate displays that we could use? For numerical variables, we can do histograms or density plots. And so let's take a look at both of these. Geom underscore histogram is the way we're going to generate a histogram. And so the variable, as I said before, is going to be wage. And so in histograms, we divide our number line up into what we might call bins, and we're able to specify how far apart we want our bin boundaries to be. And so we're going to have them be 5 units apart. And then the variable fill tells us what we want the insides, the interiors of the bars, what color we want them to be, and color then would be the external color around the bars themselves. And so we can see what sky blue looks like here, and we get a histogram. Very few respondents say they're making very little money. The biggest bar is in the $2.50 to $7.50 range, then followed by $7.50 to $12.50, and it decreases pretty sharply thereafter. You want to remember that back in 1985, the minimum wage, I believe, was $3.35 an hour. And so an alternative approach to this would be to draw a density plot where the height over any point in the plot is a function of how many values are in a range around that number. And so to get a density plot, we use geom underscore density. And I chose the color maroon 4. Believe me, if there had been a maroon 5 option, I would have chosen that. But let's take a look and see what we've got here. And so this is a density plot. Again, it resembles the histogram in form in some sense, but it's a smooth, continuous curve over our number line. And again, the height of the curve is determined by the number of responses on a range around that number. So before we go on, it's probably worth noting, we see this here a little bit at the very tail end of the density plot. It looks like there's an observation out here, and I didn't point this out on the histogram, but it's right there too. There seems to be somebody claiming to make somewhere around $45 an hour. Now that's certainly a big outlier with respect to this data set. And so what we can do is we can look and see a little bit more about that individual. But before we do that, I just want to point out that there's a web page that we can visit and get a sense of all the color options that we have in ggplot. If we click on this link, we would go here, and I encourage you to try it, and we can see a list of all these colors that we have as an options for the interiors and other aspects of our graphics. So I would encourage you to look at this, play around with it a little bit. In your homework, you're going to need to you have some freedom to choose colors, and so I would encourage you to play around with it a little bit, just to get a sense of the range of possibilities. But now let's go back to that outlier. We can apply a filter and find out what's the deal with the individuals, or it turns out to be one individual who reported a wage of greater than $35 an hour. And what we see is that this is a person that's only 21 years old, has had a couple of years of college. It looks like they're in their first year of experience. They're in the management sector, but making $44.50 an hour leads us to believe that there's probably some data entry error here. I'm guessing it was really meant to be $4.50 an hour. So to do further analysis with this, rather than work with this known outlier that seems to definitely be a misentry, we're going to remove it. And so what we can do is we can form a new data set. We'll call it CPS small, and we'll filter on all the people who are making less than or equal to $35 an hour. And that's going to remove just that single observation from the data set and won't skew some of our analysis needlessly, because we know that it can't be possibly a correct number. We'll come back and work with CPS small later on in the slideshow and in a future video. But now let's look at another type of univariate display, the bar graph. And this is a graphic that we would want to use if we were going to analyze a categorical variable, and in particular, if we want to just get raw counts for the number of individuals that fall into for each value of the categorical variable. So in Math 111 survey data set, one of the variables we know about is seat preference, front, middle, or back. And so we could create a bar plot here, and I've chosen what's going to turn out to be a very dark color, dark slate gray, to fill in our bars on the bar graph. So let's take a look at that. And we see that indeed we've got front, middle, and back, and our vertical axis is just the raw counts for the number of respondents to each of these categories in the M111 survey data set. Let's look at another data set where we can apply some bar charts too. Let's look at SAT 2010. So let's take a look at that data set. So I'll look at the help file for it. And so it's from 10 years ago now, and it's just measuring SAT results by state. And so we've got a number of variables here. I can do a view on this as well. Let's see. This was called SAT underscore 2010. And so we've got the individual states, 50 states, and a number of data columns here, including reading score, writing score, math score, and their total. So let's, rather than display a bar graph for all 50 states, what we're going to do is we're going to randomly select 10 of them. And so we're going to pipe out of SAT 2010 a sample of size 10. So sample underscore 10, or samples underscore n, and then a number inside will tell us how many individuals we want to sample from how many cases we want to take from our data set. And so we save that in the variable named 10, and then we pipe out of 10 a plot where state is on our horizontal axis and math score is on the y-axis. I'm going to fill it in with a golden color, and then stat equals identity is worth talking about for just a minute. if we call gm underscore bar, ordinarily what it's looking to do is it's looking to, as in the previous example, just count the number of respondents for a given variable. But here in this data set, we don't have, when we're talking about math score, we're not actually counting something. We're actually just wanting to uh, write down, have it graph the measurement for each state. And so when we're wanting it to generate a bar with height equal to the value that's in the data set itself, then we're going to use stat equals identity. So we didn't do that in the previous bar graph when we were going in and counting the number of individuals who responded to each seat preference. And so what we get here then is we get a bar graph, and it's the data values in the math column that are plotted here. And we see that the data is arranged in alphabetical order of the 10 states that were selected. What I might want to do instead, though, is arrange our output so that we go from lowest to highest. And we can use a command reorder inside our initial aesthetic in order to do that. And so if we want to do x equals reorder state comma math, that's going to shuffle the values of our bars, so they're no longer going to be in alphabetical order, but they'll be arranged in order from low to high value of the math value. And indeed, we see that is what we get here. The next slide contains an example where we dress up our plot just a little bit. We're going to add a label on the y-axis, but we're also going to slant our text for each of the values of the states at a 45-degree angle. And so if we look at this theme command, that's going to take care of angling our categorical values here, our states. So that's what we can do with univariate displays. In our next video, we'll be doing some things with bivariate displays.